What's up? Respect. This is still the great teacher Alcantara here with another video. This time around, we're going to talk about the elimination method. So for this specific video, we're going to discuss easy examples until some average examples, I guess, that we're going to talk about, wherein we will discuss how to eliminate certain variables in different ways and some certain skills that you need to remember so that things will work out well for you. So let's just jump right into it. Let's start and discuss elimination method. Same case with the learning targets from the previous lessons. We're going to deal with this certain method to deal with linear equations in two variables. But again, systems of it. We're going to deal with two equations for that certain system. And as much as possible for this one in particular, we're working on purely word problems so that, you can get trained with it. And let's get it out of the way. It's important that you remember some things here first, the concept of opposites. And basically the reason why we're going with this so that you remember the concept of eliminating something or making something become zero. So when you deal with the opposites, for example, here you have 9. The opposite of that is none other than negative 9. For negative 22, the opposite of that is positive 22. For 5, the opposite of that is negative 5. For negative 7, the opposite of that is positive 7. So we're just driving by all of these things that you need to recall because it's the same thing with the additive inverse. So the additive inverse is basically the thing wherein if you add these two integers, the answer is 0. Basically, you have a certain given and just change its sign to whether from negative to positive or from positive to negative. And when you combine both terms, the answer is 0. This will be an important skill later as we proceed with the elimination method. So following the same thing with the opposites, you can have, for example, 9x. The opposite of that is negative 9x. For negative 22y, the opposite of that is the positive version of it, 22y. For 12x, it could be negative 12x. And lastly, the opposite or the additive inverse of negative 27y is positive 27y. Again, the important concept here that was being detailed with the opposites and the additive inverse is the concept that these two things are the same except for their signs. And when you combine them by addition or subtraction, the answer is 0. So that is our goal. So now we will apply these skills in applying the concept of the elimination method. So our first word problem, Itadori is forced to solve a system. And this time around, it's the same given from the previous video, but this time around, it's in line with the elimination method. So you have here x minus y equal to 5 and x plus y equal to 19. The important thing that I want you to understand is we have to apply an appropriate operation. So you have x minus y equal to 5. Let's write that down here. And you have the other one as x plus y equal to 19. So the operation that we can do here to eliminate a certain variable is by addition, or you may also do subtraction if you want to. So if I do addition, what I will do is simply add the terms one by one. As you can notice, negative y and positive y are additive inverse of one another. So there, you can see the application of the recall that we did earlier. So x plus x, that will be 2x. And then negative y plus y, that will be equal to 0. And then 5 plus 19, that will be equal to 24. Hence the term elimination. So we managed to eliminate the y variable because we added these two equations. Okay, so x plus x, 2x. Negative y plus y, that is 0. Then 5 plus 19, that is 24. So our equation now is 2x equal to 24. To isolate the x variable, divide the entire thing by 2. You will get x is equal to 12. Once you get x is equal to 12, substitute that to any of the equations. So let x equal to 12. This is the thing that we did in the substitution method. So I'll use the second equation. So x plus y equal to 19. So 12 plus y equal to 19. Subtract 12 to both sides. you will get y is equal to 7. And again, you can form an ordered pair here. You'll have 12, 7. Since you have an ordered pair as a result, you can say that the system is consistent and independent because we have one solution, meaning that we have intersecting lines here. And here, to address the possible concern, what if I decided to do subtraction instead? In some cases, it is easier to do addition. In some cases, it is easier to do subtraction, depending on the situation itself. Because if we do subtraction here, we can have x minus y equal to 5, x plus y equal to 19. If you subtract, you have to be careful because you have to consider every single thing. So for example, if you continue here, x minus x, that is 0. But what is negative y minus y? So that's the thing. If you're good with integers or negative terms, there's no problem with that. So negative y minus y, that will result to negative 2y. And what is 5 minus 9? 5 minus 9 will result to what? Why am I lagging? Wait, x minus x, 0. Negative y minus y is negative 2y. Then what is 5 minus 19? Oh yeah, that's why I'm lagging. I'm like, there's something missing here. Okay, it's 19, not 9. So 5 minus 19, that's negative 14. Forgive me for that. I lagged in there for a long time. So negative 2y is equal to negative 14. Isolate the y variable, divide by negative 2. Oh god, I lagged. So this will be y is equal to 7. So as you can notice, we arrive with the same value of y. If you continue this, you're going to get the same value of x. So either way, again, you're going to have the same result. It's your choice which one you find the easiest, addition or subtraction. So if you have the possible questions like, sir, when doing elimination method, are we just going to use addition or subtraction? By the process of eliminating, yes. But later, we're going to use either multiplication also for something that is yet to be discussed. So for now, we're just going to focus on doing addition and subtraction first. Okay? So let's make this clearer because I stumbled in this first example. Apologies. I cannot repeat and edit out a lot. It's difficult, guys. Wait lang. Let's go with the next one. So now we have a word problem. So again, we're just practicing these two skills all together. So we have here, Megumi is planning to buy headphones for his classmates so that they could leave him alone once in a while. So one Sony headphones and one Beats headphones is worth $600. Two Sony headphones and one Beats headphones is worth $950. How much does each headphones cost? So just like earlier, it's important to label them first, right? So let's say that the X variable will represent the Sony headphones, and then the y variable will represent the Beats headphones. The first statement says one Sony headphone, so meaning let's say that we have X. One Beats headphones, let's say that is Y. Since we're saying that altogether it's worth 600, so you're going to add those two things, X plus Y, and it is equal to 600. Similarly, two Sony headphones, so let's say 2X and one Beat, so Y. So add them, that will be equal to 2x plus y equal to 950. So those are our two equations. Now there's something important that I will say and show again later here. So we're hitting a lot of things here, a lot of techniques already. So let's now start with solving. So again, you may work on this. As you can notice, everything is positive. So if everything is positive, you cannot eliminate anything if you do the addition method. Instead, it would be easier. Of course, you cannot eliminate using add. Everything is positive. So you have to subtract. So you have x plus y equal to 600, and then 2x plus y equal to 950. The first possible way is just sticking to how they are presented and do subtraction. So I would subtract x with 2x, y with y, and then 600 with 950. X minus 2x will result to negative x. Y minus y is 0. 600 minus 950 is negative 350. Therefore, if you continue, negative x is equal to negative 350. Isolating the x variable, divide both by -1. You're going to get x is equal to 350. Doing so, we may start by looking for the y variable. So we have the first one, so let x be 350. We'll have x plus y equal to 600. 350 plus y is equal to 600. Subtract 350 to both sides. You're gonna get y is equal to 250, meaning the Sony headphones is worth $350 and the Beats headphones is worth $250. And again, there's another possible solution to this, which I'm going to show. Now, the good thing about systems of linear equations is you can maximize the way that it is presented. You may interchange their possession. So what I can do here, so that I can avoid the negative signs, I'll put the equation with higher terms above instead. So what I'm trying to say here is I'll have 2x plus y equal to 950 first, followed by x plus y equal to 600. Mind you, they're the same thing. I just change their possessions so that when I do subtraction method to eliminate, you will have 2x minus x, that is x, y minus y, that is 0, and then 950 minus 600, that's automatically 350. So it's positive already. So this is what I'm talking about. Again, you have the freedom to interchange their possessions so that the answer will be positive. There's nothing wrong with that, because at the end of the day, you're gonna arrive with the same answer. So to answer this word problem, the value of one Sony headphones is $350, and the value of one Beats headphones is worth $250. And when I did this word problem like a year ago or two, this is like the floor price of the regular headphone. So who knows? Okay, so that's it. That's how you work on that one. Apologies, I'm no longer gonna continue the second process because it's gonna end up the same thing. Okay, so let's go with another word problem. This time we have Nobara, and she's planning to buy albums for her besties. Currently, the store near her has a sale where all albums of the same genre has the same price. 5 K-pop albums and 7 rock albums is worth $130, and 3 K-pop albums and 7 rock albums is worth $106. So how much is one K-pop album and how much is one rock album? So again, the important thing here is we label them. So let's say that the X variable is the K-pop albums, and let's say that the Y variable is the rock albums. So it says there 5 K-pop albums. So our first equation will be this one right here. It will be 5x 7 rock albums, so 7y, and worth 130, so 130. Our second equation, 3 K-pop albums, 3x 7 rock albums, 7y, and then worth 106. So those are our equations for this example. To continue, we can now work on eliminating something in particular. And again, everything here is positive. So the thing that we're going to do here in order to eliminate a variable is by subtraction. 5x plus 7y equal to 130. 3x plus 7y equal to 106. So subtract the two equations. You have 5x minus 3x, that is 2x. 7y minus 7y, that is 0. 130 minus 106, that is equal to 24. So 2x is equal to 24. So divide the entire thing by 2 to isolate the x variable. You will get x is equal to 12. So as you can notice that we have x being 12, we can now substitute that to our equations. So we can use the first one or the second one. Either way, we're gonna have the same answer. So let's have our first one instead. 5x plus 7y equal to 130. Let x equal to 12. So you'll have 5 times 12 plus 7y equal to 130. You'll have 60 plus 7y equal to 130. Subtract 60 to both sides to isolate the y variable. you will have 7y is equal to 70. Divide the entire thing by 7 so that you can isolate the y variable completely. You'll have y is equal to 10. Meaning that your K-pop albums is worth $12 and your rock albums is worth $10. Now, forgive me if I'm not identifying the system anymore in these examples for the time being, because as you can notice, all of the examples have a solution. So again, the thing that you can note if it's inconsistent or dependent is similar with the substitution method process, because we're dealing with equations now. So that's how it's going to look like. Okay. So now let's proceed with our second. Oh no, I think it's the fourth one. Now we have Gojo. So Gojo is planning to buy one kind of shades from both Gucci and Versace since he destroys them easily. But here, the problem is that it is in a package. So 4 Gucci shades, 6 Versace shades, that's worth 2,050. While 2 Gucci shades and 6 Versace is worth 1,550. So let's label them first. Let X be the Gucci shades. Let Y be the Versace shades. So for our first equation, it says there, 4 Gucci shades, so 4x, 6 Versace, so 6y, equal to 2050. Next, you have 2 Gucci shades, so 2x, and then 6 Versace shades, 6y, equal to 1,550. So now, what we will do is eliminate a certain variable. In this case, we're going to eliminate the 6y part because they are the same thing. All are positive, so we will do subtraction. Now that we have this, subtract both of them. 4x minus 2x is equal to 2x. 6y minus 6y, that is 0. 2050 minus 1,550, that will be equal to 500. So you'll have 2x is equal to 500. Divide the entire thing by 2. So that will give you x is equal to 250. So using this, we now have the value for our Gucci shades. Now let's try out for the Versace one. So let's identify the y variable. So we can use, I'll choose the first one instead. So let x equal to 250. Our equation is 2x plus 6y equal to 1,550. So 2 times 250 plus 6y is equal to 1,550. You'll get 500 plus 6y equal to 1,550. Subtract both sides by 500 to isolate the y variable. You will get 6y is equal to 1,050. To isolate the y variable completely, divide both by 6. You will get y is equal to, what will be the answer here? 175. So those are your prices. So you have X being 250, that's for Gucci. So 1 Gucci shades is $250 and 1 Versace shades is worth $175. So just write it in a complete sentence when you're being asked to deal with word problems. Okay? So we have some more. Of course, we have some more. Let's have this one. Now we're gonna deal with Todo. Okay. So Todo is planning to buy raffle coupons to meet his favorite J-pop idol. The following is the lucky package for raffle coupons. Package 1, 8 concert raffles and 9 meet and greet raffles is worth 137. Package 2, 10 concert raffles and 9 meet and greet raffles is worth 151. Since he is broke, he is considering to buy one each. How much does one concert raffle cost, and how about the meet and greet raffle? So just like earlier, label them. So X is the concert raffle and then the Y is the meet and greet one. Our first equation will be 8x because 8 concert raffles. And then 9 meet and greet, so 9y. And then worth 137. Second package, 10 concert raffles, 10x. 9 meet and greet, so 9y. And then worth $151. So in this case, I would like to, since I'm hoping that you guys get already the technique here, since as you can notice, the second equation have higher values for terms, I'll put that first, okay? So that it will be easier for us to eliminate something without negative values. So 10x plus 9y is equal to 151, and then we're going to subtract 8x from it. 8x plus 9y equal to 137. Doing so, by subtraction, 10x minus 8x is 2x, 9y minus 9y is 0, 157 minus 137 is equal to 14. So we have 2x is equal to 14, divide the entire thing by 2, you will get x is equal to 7. And then you may substitute that to any of the equations, so that x equal to 7. I'll use the second one, 8x plus 9y equal to 137. 8 times 7 plus 9y is equal to 137. Excuse me, 56 plus 9y equal to 137. So subtract 56 to both sides. You'll get 9y equal to 81. Yeah. Is it 81? Yep, it's 81. So divide the entire thing by 9 and you will get y is equal to 9. So therefore, for the concert raffles, it's worth $7. And then for the meet and greet ones, it's worth $9. So just take note of that. So that answers Todo's concern. Let's hope that he meets his favorite J-pop idol. We'll see. So let's have some more word problems. This time around, it's going to be a bit different. So this is the challenge part. So Itadori thought he was done, but Gojo Sensei left him with another SLE-TV, a system of linear equations to solve by elimination method. The following equations are x plus 2y equal to 3, 3x plus 5y equal to 7. Is it possible to immediately eliminate a variable in the given? Now, that's the thing that I would like to emphasize. We cannot immediately do addition or subtraction. The reason behind that is because there are no terms that are the same for both. So in this case, since we're dealing with two equations where it is not yet determined, or it's not easy to eliminate something because there's nothing that is the same. So what we have to do is to focus on our guide. The first thing that's being said here is we focus on one variable that we would like to do. That's why we have two sets here, two possible solutions. We can match the x terms and we can match the y terms. It's our choice which one we would like to do. So to match the x terms, what we can do here is to manipulate one specific equation only. So we have x plus 2y equal to 3, and we have 3x plus 5y equal to 7. Since we say match the x terms, we want them to have the same numerical coefficient. Since x has a numerical coefficient which is 1, and 3x has a numerical coefficient is 3, we want them to have the same thing, which is 3, right? That's their LCD. So we will simply manipulate the first equation by multiplying it by 3 altogether. Meaning, this will give us 3 times x, 3x, 3 times 2y, 6y. 3 times 3, that is 9. So in this case, if we continue, you can now have our new system that is equivalent to the previous one, where both of them have 3x altogether. So we can do subtraction method here. So to eliminate 3x's, so that will be 0. 6y minus 5y, that will give us y, and 9 minus 7, that will give us 2. So in this case, we already have the value, y being 2. So let y equal to 2. Let's substitute that to any of them. Let's use the first one, x plus 2y equal to 3. So you can have x plus 2 times 2 equal to 3, x plus 4 equal to 3. Subtract 4 to both sides. You will get x is equal to negative 1. So therefore, your ordered pair here is found at negative 1, 2. This is intersecting lines, and this is consistent and independent. So that's the thing that I want to emphasize here. Now, what if you wish to do the other one, which is matching the y terms? There's nothing wrong with that if you want to do it that way. So what you can do there is make their y terms the same. You have 2y and 5y, right? So in here, instead of just multiplying or manipulating one equation, you have to do both. So you have to identify the LCD of the numerical coefficients here, 2y and 5y. So the numerical coefficient there is 2 and 5. The LCD of that is 10. So basically for each term, multiply it by what will make it the same. So for the first equation, I'll multiply this by 5 so that 5 times 2y will result to 10y. Then here, the second one, I'll multiply by 2. So 2 times 5y will result to 10y. So we'll have 5x plus 10y equal to 15. And then we have the next one as 6x plus 10y equal to 14. And if you do the subtraction method, just like earlier, you will have 5x minus 6x, that is negative x, 10y minus 10y, that is 0, 15 minus 14, that is 1. So negative x is equal to 1. Divide the entire thing by negative 1. So you will see that your x is indeed equal to negative 1. So again, we don't have to continue anymore because it's going to result to the same thing when you substitute it. Okay, so what I'm trying to emphasize here is this. You can solve it either by matching the x terms or matching the y terms. But you don't have to do both. Choose the easiest. At times you have options, but at times again, it's both difficult. So we'll see. Let's have another example. And this is actually the last one, I promise. So the last one, finally. So we have 9x minus 5y equal to 2, and we have 3x minus 4y equal to 10. So again, we're trying to identify which one to manipulate, which one to isolate. In this case, we have 9x, 3x, and then we have 5y, 4y. So which one would you like to match? Now, again, using our critical thinking skills here, the easiest one to manipulate would be the x's, because you're just going to multiply the second equation. That's your choice. You may do the second one, the y's, but you're going to multiply both. So let's try to match the x terms. Match the x terms. My handwriting is horrible now. Please forgive me. I've been writing for now 90 minutes. Okay, please forgive me. So now we'll have 9x minus 5y equal to 2. We have 3x minus 4y equal to 10. I'll multiply the second equation by 3 so that they will both have the same x terms, which is 9. So this will result with 9x minus 5y equal to 2. 9x, 3 times 3x, 3 times negative 4y, negative 12y, 3 times 10, that's 30. So subtraction, to eliminate the x's. 9x minus 9x, that is 0. Negative 5y minus negative 12y, be careful with that. So that will be 7y. Explanation, negative 5y minus negative 12y. Meaning, this will be negative 5y plus 12y. Therefore, you get 7y. Okay? 2 minus 30, that will give you negative 28. So 7y is equal to negative 28. Divide the entire thing by 7. Your y will be equal to negative 4. So that's it. You have negative 4 there. So you can use this now to substitute to any of the equations. So let's use the first one. So let y equal to negative 4. So 9x minus 5y equal to 2. 9x minus 5 times negative 4, be careful with this, equal to 2. Negative 5 minus 4. Negative 5 times negative 4, that will give you 9x plus 20 equal to 2. So subtract both by 20. To isolate the x variable, you will have 9x equal to negative 18. To completely isolate the x variable, divide both by 9, and you will get x equal to negative 2. So your ordered pair can be found at, why did I write x? This should be negative 2, negative 4. So this is intersecting lines. This is consistent. And at the same time, this is independent. So that's how it works. Again, if you want to try and match the y variables, there's nothing wrong with there. There's nothing wrong with that. You may multiply the first equation by 4, the second one by 5. Then you may could continue from that one to eliminate a certain variable. So that's it, basically. You have the ordered pair at negative 2, negative 4. It's intersecting. consistent, and independent. So as you can notice, Gojo is happy because it's now done. Same case with Itadori. Same case with the great teacher. I'm done. I'm happy. I'm glad. Okay. See you guys. And that ends the video about solving for systems of linear equations in two variables. Always remember to take note of the examples, practice them on your own so that you'll get used to it and master the concepts. And always remember what's up, and that is respect. And in case you don't see me, good morning, good afternoon, good evening, and good night. Bye bye bye.